For more than a decade, the world of software has been dominated by a single mantra, a philosophy famously born out of Silicon Valley: move fast and break things. This idea championed rapid iteration and immediate execution above all else. It rewarded shipping features at lightning speed, often at the expense of structural integrity, good documentation, and long-term stability. And for a while, it worked. It generated immense economic value and powered the startup boom. But today, we're facing the consequences: a global digital infrastructure burdened with finicky, poorly performing, and insecure legacy systems.
But what you can't see is what's hiding inside the walls. The builders, in their haste, forgot to install the fire suppression systems. They used standard bolts where reinforced, earthquake-proof ones were required. They skipped the emergency power systems for the elevators and failed to implement the complex, redundant plumbing that prevents cascading failures. They built 80% of a perfect building, but the missing 20%? That's the part that ensures it doesn't catastrophically fail. This isn't a hypothetical. This is the hidden crisis happening right now at the heart of the AI revolution, and it's forcing us to completely rethink what it means to build the future.
Hello, and welcome to Mindcast. I'm your host, Will, and this is the podcast where we explore the frameworks, mental models, and paradigm shifts that are shaping our world. Today, we are diving deep into one of the most profound and, frankly, underreported shifts of our time: the fundamental change in how we create software, driven by the rise of what are called agentic AI workflows.
Our guide for this journey is a fascinating document I came across, titled The Epistemological Shift in Software Engineering: Revaluing Human Cognition in the Era of Agentic Workflows. Now, I know that sounds incredibly academic, but stick with me, because the ideas inside are absolutely electric, and they have implications far beyond the world of coding.
So, here's the promise for this episode. By the end of our time together, you're going to understand the invisible crisis of comprehension debt. You'll learn about the radical new methodologies like vibe, then verify. Discover the new professional archetypes emerging in this field, and explore the critical behavioral science needed to navigate this massive shift. This isn't just about technology, it's about value, cognition, and how we must adapt to work alongside autonomous machines. So let's start with our first key insight: the hidden threat of comprehension debt.
For years, software engineers have talked about something called technical debt. This is when you consciously take a shortcut to ship a product faster, knowing you'll have to go back and pay off that debt later by fixing it properly. It's a calculated risk. But comprehension debt is something entirely new and far more dangerous.
The document describes it as the cognitive gap between the sheer volume of code an AI can generate and the amount of that code any human on the team genuinely understands. And this gap is growing exponentially. Think of the iceberg analogy used in the text. Above the water, you have the 80% of the code that the AI generates flawlessly. It works, it passes basic tests, and it looks clean. This is the part that makes productivity charts go through the roof. It's the visible, functional part of the application. But beneath the surface lies the other 20%, a dark, tangled mass of what's missing. The AI, without deep context, consistently fails to implement crucial non-functional requirements: robust security checks, graceful failure modes, rate limiting, and all the other boring but vital plumbing that keeps systems from collapsing under pressure. This is the comprehension debt.
The result is that what the paper calls the theory of the system, the collective mental model of why things were built a certain way, evaporates. When a critical bug appears at 3 a.m., no human on the team can quickly figure out the original intent of the AI-generated code. They have to mentally reconstruct the logic from scratch, wasting hours trying to untangle a mess they didn't create. The time saved in generation is paid back with interest during maintenance. That is the essence of comprehension debt. So, if hyper-fast code generation is creating this invisible time bomb, how do we defuse it? This brings us to our second key insight: the rise of new methodologies, namely spec-driven development and a culture of vibe then verify. The old way of working with AI was basically being a prompt whisperer, trying to coax the right output from a chatbot with clever natural language. The document argues this fails at any serious scale because it's unpredictable and lacks rigor.
The new solution is called spec-driven development, or SDD. Here, the primary engineering artifact isn't the code anymore. It's the specification. Think of it like this. Instead of just telling your builders to build a strong skyscraper, you hand them a 1,000-page legally binding blueprint that details every single bolt, every electrical circuit, and every safety protocol.
This spec is a hyper-strict, machine-readable contract. It defines the business goals, the constraints, the non-functional requirements, and the exact criteria for success. The AI agents are then forced to operate within the rigid boundaries of this contract. The human's job shifts entirely upstream, from writing code to engineering the perfect set of instructions. This new workflow is perfectly captured by a cultural philosophy popping up in leading engineering teams: vibe, then verify.
The vibe phase is where creativity and speed are unleashed. Engineers use AI to rapidly prototype, explore different architectures, and generate initial scaffolds of code. It's the generative, expansive brainstorming part. But, and this is the crucial cultural shift, everyone is trained to treat this output as inherently unreliable. It's just a vibe, a plausible approximation of a solution that should never be trusted. Then comes the verify phase. This is where human attention becomes critical. Every single line of AI-generated code is subjected to uncompromising automated quality checks, deterministic guardrails, and rigorous audits. Independent critic agents might even be deployed to evaluate the code against the original spec. The human is the ultimate arbiter, the final checkpoint. Their value is no longer in their typing speed, but in their critical judgment. So, if the daily work is shifting from writing code to writing specs and verifying outputs, what does that do to the identity of a software engineer? This is our third and perhaps most profound key insight: the redefinition of the engineering profession into new archetypes.
The paper argues that the monolithic role of the developer is fracturing into highly specialized functions that are better suited for managing AI. First, you have the M-shaped supervisor. This person is a broad generalist. They don't need to be the best coder, but they are fluent in AI capabilities, systems thinking, and business operations. They are the human orchestrators, the conductors of the AI agent swarm. Their main job is to translate high-level business goals into those strict executable specifications we just talked about. They set the rules of engagement and monitor the whole system.
Complementing them is the T-shaped expert. The T-shape represents their skills, a very deep vertical bar of expertise in one specific, highly technical area, like low-level cryptography or process chemistry, and a broad horizontal bar of knowledge across adjacent fields. These are the people who handle the complex edge cases and subtle anomalies where the AI systematically fails. Their job isn't to do routine work, but to codify their deep expertise into patterns and rules that can then be used to teach the AI agents, making the whole system smarter.
And finally, we get the most futuristic and fascinating role: the systems mathematician. This is wild. As AI becomes capable of not just writing code, but also writing formal mathematical proofs of that code's correctness, a new human skill is needed. A theorem prover can guarantee a proof is mathematically sound, but it can't guarantee the proof actually corresponds to the real-world safety requirements. The systems mathematician doesn't write day-to-day code. Their job is to audit the alignment between human intent and the mathematical proofs the AI provides, ensuring the system is provably safe and does exactly what we meant for it to do, not just what we literally asked it to do.
From creator to curator, from builder to overseer. This is the profound identity shift at the heart of the agentic age.
Okay, that was a lot. We went from the hidden danger of comprehension debt to the new paradigm of spec-driven development to the fracturing of the engineering role. So let's synthesize this into 3 big, actionable takeaways for you to consider.
First, speed is a trap. In the age of AI, the most seductive promise, raw generation speed, is also the biggest danger. The move fast and break things philosophy is officially dead. The new focus across the board is on rigor, foresight, and uncompromising verification. The most advanced organizations are deliberately slowing down their process to build the right guardrails, knowing that true speed comes from safety and stability, not just rapid creation.
The most valuable human skill is asking the right questions. The future of knowledge work isn't about knowing the answer or even how to produce the final product. It's about being able to perfectly define the problem, articulate the constraints, and specify the desired outcome with absolute clarity. The value is shifting from being the bricklayer to being the master architect who creates the flawless blueprint. Clarity of intent is the new currency. This means that our educational systems and professional development programs need to evolve to prioritize critical thinking, problem framing, and the ability to communicate complex requirements in a structured way. And third, this is coming for every field. While our source document focused on software engineering, this pattern is a blueprint for the future of agentic work everywhere. Think of lawyers supervising AI agents that draft and review contracts, with the human's role being to set the strategic constraints and verify the output against legal precedent. Think of scientists defining experimental parameters for an AI to execute, with the human verifying the results. The model of human as orchestrator and AI as executor is a universal one. The job for all of us is shifting from doing the thing to defining and verifying the thing. We must all become adept at specifying our intent with precision and developing the critical skills to audit the work of our AI counterparts. This is the new literacy of the 21st century. We are witnessing a fundamental revaluation of human cognition. The true value we bring in this new era lies not in our ability to create things rapidly, but in the wisdom, discipline, and systemic understanding required to govern the powerful intelligences that will. This is a profound shift that requires us to rethink our roles and responsibilities in a world where AI is a ubiquitous partner in creation. That's all the time we have for this episode of Mindcast. I hope this gave you a new lens through which to view the ongoing AI revolution. If you found this insightful, please consider subscribing wherever you get your podcasts. I'm Will. Thanks for listening.